welcome to Coding Missions. Today we're gonna learn about face detection using Python. Okay. First of all, before going to go into the face detection concepts, let's get started with the pre-requirements of this course. Okay. First, you have to make a folder. Okay. So the folder is, let's create a folder in our laptop. So I will select my P directory and I'll create a folder. I will name it as course. Okay. Now, okay. This is the first thing that we have to do. And the second thing, okay. The second thing is we have to install the required modules here. Okay. The required Python modules or library is in this course we have only worked with one module, right? So that is OpenCV, computer vision module. So let's install that module. You have to go to cmd command prompt, and in cmd you have to type pip install opencv dash python. So make sure that you all are well okay with the pip here. Some of the lab some of the Python installing at the time of installation you might have not make the pip installed. So please take care and follow respective steps to install pip. Okay. So already my requirements have been satisfied because I have already downloaded the library here. So it is ready to use. Okay. Now, now what we have to do is we have to create a Python file. Okay. Let's open IDLE. In IDLE, oh yeah. In IDLE, what we have to do is we have to create a new file and save it in Control S. So I will save it in the folder which we have created with the name courses. So the file name should be face detection, right? Enter. Okay. Now what we have to do is first let us see the other requirement here. Okay. The other requirement is we have to get a image so that, okay, let me show you the image. So this is the image which I used to detect the faces. So I will just move this image to the folder. Right. The image is moved, and now let me write the code here. So first, since we have installed the module library file, we have to import that. So the syntax for that in Python is import keyword space module name. We have installed opencv dash python, but the module at the time of importation that should be imported as cv2 computer vision module. Okay. Next next the first thing we have to do is nothing but we have to load the cascade file. So what is a cascade file? A cascade file is nothing but a uh, file, a form of file. The form of file we are using is xml. So xml file, this cascade file, what it contains means it contains the features and patterns data. Okay, this full the xml sheet is full of features and patterns data which is used to detect the face of an image or an video of the image. I mean, the face will be detected in the image or video using the patterns and the data which is presented in that xml sheet. So we have to make the cv2 to take that xml sheet and get the knowledge from it. Okay. So what should we have to do is now let's create an object that is face cascade. So face cascade is a object uh, which we gonna do, what we gonna do with this, right? So CV2, since in CV2 there is a class called cascade classifier. Yeah, right. So here we have a class called cascade classifier here. Okay, cascade classifier is the class which is present in the CV2 module, right? It is used to make the CV2 to know the features and the patterns which is present in the XML sheet. So we use hair cascade method. Yet there are multiple methods to detect faces in images or video, like as neural using neural networks or any other approach. There are convolution networks, any other approach. There are many kind of approaches, but here hair cascade is a one type of approach where we can use to detect faces in videos and images through machine learning. Okay, hair cascade is nothing but a machine learning uh, part of machine learning, right? Like neural networks and convolution neural networks. These are whole concepts. Yeah, one other concept is hair cascade. One of the concept is hair cascade. Okay, so how we gonna that hair cascading XML file? Okay, we have installed OpenCV module in through command prompt, right? So what we have to do is the next primary thing we have to do is we have to go to my file manager and then go to Python. I mean the where you have installed the Python, right? So here in my softwares, I have installed the Python folder. So go to that folder. You will be having this all. Okay. In that, go to lib, and in lib we have to go in lib we have to go to site packages, right? So here is the site packages, right? So we have moved into the site packages folder, and then in the site packages folder there will be a folder called cv2, right? So yeah, cv2. In this cv2 there is a another folder. In that cv2 folder there is another folder called data, right? So go to data folder, and here are the different hair cascading files here. So you can the required hair cascade file for uh, face detection is will be, yeah, this one, hair cascade frontal face underscore default, right? So this is the XML sheet which we require for the face detection in cv2 module. Okay, so let's copy the path here. Let's copy the path and move here, and in Python 5 we will just paste the path. Done, right? Okay, if you are not okay with this all, that means you don't know where the Python has installed in your system, then there is another technique to do that. That is nothing but go to this PC and search for cv2, right? Here you will get a folder that will be in a Python folder. So cv2 folder, and open that folder. You will get to the here the data will be present, data folder. If you go data folder, done. Here is the XML sheets, different XML sheets, right? In this, the required XML sheet is the 10th sheet from the top. From the top from the top the required thing will be in the 10th element, right? That means first element, second element, third one, fourth, fifth, sixth, seven, eight, nine, 10. Tenth element is the required XML sheet which is used to face detection. Okay, this is the two techniques you can go through. So you can go through any one of that to know to find the XML sheet, hair cascading frontal face XML sheet. Okay, done. Let's get into the code now. Okay, so what is this logic represents? Let's write the comment here. What is this logic represents? So this logic represents to load the cascade, right? This logic represents to load the cascade. Nice. Now what we're gonna do? Next thing we are going to, what we have to do is we have to load an image, right? So what the image we want to load? Let me take an object that is a image. Uh, then in CV2 module there is a method called imRead, which means image read. Okay. So CV2 dot how to access the button? We have to access through CV2 dot im read, right? It is a method, so we have to open the bracket and close the bracket. Then in this, in double quotes, we have to pass the address of the image file. Okay, image which image you want to pass, you have to pass the address. Here we have created a folder. Starting at the starting of the course, we have created a folder named course. So and then we have shifted an image to into that folder, right, into the course folder. We have shifted an image. So since we have shifted that image, we can directly write the name of the, I mean the name which we have saved. We have saved that image with a name, right? So we can use that name directly, no need for other names. Okay, so the image name which I have saved is image dot, even the extension should be needed. So jpg is the extension which is given to that image. Okay, okay, so let's write the comment here. What's the comment will be? It comment will be loading the image, loading the image, right? So we have loaded the image, and next what we have to do? So we have to do is here the image which we have imported using imRead method, which is there in CV2, but imRead method takes the image in BGR format. Okay, let me explain you clearly. RGB format is nothing but a color pixel format. Okay, red, green, blue, RGB colors. So these three colors decides the color of the whole image. Okay, how the image should be shown, how colorful it is, it will be represented through RGB colors. The pixels contains this color data. Okay, so for RGB colors, ImRead takes the image as a BGR image. BGR means nothing but the reverse of the RGB, that is blue, green, red, right? So the image color doesn't change, but the format of the RGB will be reversed, BGR. Since the colors which we had, that means the RGB three colors, we have the same colors BGR. Okay, same colors, blue, green, red, blue, green, red, same colors. So the image doesn't seems like nothing will be changed. It will be not changed. Okay, so the image will be same. Okay, now what the task we gonna perform is we have to convert this BGR image to a gray image. Why? The reason is the gray image is nothing but a image which is like a black and white one. The BGR image is a colored image, right? So why the logic is needed? Why the process, this much process is needed for conversion of the uh, why the color should be converted? The question is this. The answer is, while processing a colored image, it takes more computational time, more computational resources for the processor. So decrease these things, to minimize these things, to optimize our code, we will just change the colors of the image, that is to black and white, that means the gray image, which is a convert the colored image to the gray image, right? So we will have to write the logic for that now. See, we have stored the color image, the image which we have in our laptop in img object, right? So we have to store. We will store a the black and white image. That means the gray image in gray object. Okay. So gray object. Uh, how we can modify the color image? So there is a method in CV2 module, that is CV2 dot CVT capital COLOR. Sorry, COLOR. CVT color, that means nothing but convert color. Okay, so CVT dot CVT color is a method which is present in CVT module. Okay, so it has two parameters. We can pass two parameters here. The first thing is the colored image, that is which is stored in the object img, right? First thing we have passed an image into this. Next, the second parameter should be from which color to which color it should change. This is the second parameter which we have to pass to this method. Okay, there is a object variable in cv2 module, that is cv2 dot. Okay, the variable is, all should be in capitals for this variable, COLOR color underscore BGR2 G gray. Yeah, this is the gray image which you're gonna have. So color to colored image will be converted. That means the BGR color BGR will be converted to gray. This is the variable represents of. Okay, I think you have understood everything. Now, let's write the comment here. What we have done. What we have done is, uh, we have converted, right? Sorry, converting BGR image to gray image, right? So, let me show you the image, right? I mean, let's show the converted gray image. Okay, let's see what's the colored image is converted to the gray image. Okay, then, how we gonna see? Okay, that's the main thing here. In cv2 module, there is a method called imShow, which is nothing but a image show short form. imShow, imShow is the method, right? So image show, which image should be shown here? Which image should be shown here? It has two parameters. Okay, first parameter, the name of the image. That means which means it shows an image, right? imShow shows an image. Okay, that's good, that's cool. But what should be the name of that image? That is the first parameter which we're going to pass. The first parameters will be passed in double quotes. So the content in the double quotes which we give will be the name of that image. Okay, for that instance it will be the name of the image. I will pass gray image. Okay, gray image will be the name of the image which the interpreter will show while we run this. Okay, image is the color image, which I mean, okay, sorry, image will be the color image. Okay, but in this image imShow method, what we want to see, we want to see the black and white image. But black and white image is stored in which variable, which object? It is stored in gray, right? So we have to pass the second parameter as gray. Both two parameters should be separated by a comma. Okay, cool. Now let's run this code. Let's see what will be the output. See here, the name is gray image, right? The name is gray image, and the image is turned into black and white, right? As we as we spoken from the starting, the image will turn into black and white. So the image is turned into a gray. That means a black and white image. Okay. Now let me close this and let me kill the program. Right. So we have seen the black gray image. Okay, next, let's write the comment for this. The comment will be showing gray image, right? Yeah, image is shown. Cool. Next thing we have to do is what we have to do. What we have to do is we have to perform the face detection logic. See, we have turned the colored image into the black and white, I mean gray image, right? Okay, we have decreased, as we discussed earlier, we do this process because of the decrease the processing time, and computational resources, decrease the computational resources, computational time, computational speed, right? This all. So we are done with that. We have made the changes. We are done with that. So we have to move to the next step here. The next step is we have to detect the faces in the image. How many faces and where are there? I mean, uh, if the if you consider image, so with the whole exact like a graph, in terms of graph, it will be like x-axis, y-axis, height, width, etc, 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 when we consider the image into a graph. So what we have to do is we have to detect the faces in that image, and how many faces count. Okay, let's get into the logic, so we will get more clarity here. First, what we have to do is uh, we will take a object that is sorry we will take a object that is faces. Okay, so faces is an object which stores the values of the how many faces and the data of the faces, that is the x, y, height, width, right? Once we are done, we will be more clarity, it will be more clarity once we have completed the logic and see the output. Okay, how we gonna do that? See, at the starting, we have imported the XML hair cascade classifier. I spoke earlier, this classifier has the data which is a which is nothing but a features and the patterns which are required to detect the face in the image or in video, right? So we have to use that. The whole thing, the XML sheet content and the whole thing is stored in the variable face cascade, right? So we will use that variable object face cascade, face underscore cascade, right? So face cascade is done. It's not a method, it's a variable which we have created, right? So face cascade, what we have to do, there is a method called in face cascade. Since we are using the variable face cascade, that means indirectly we are using the cv2 module dot classifier, cascade classifier, right? So in cv2 module there is a method called detect m capital multiple scale, detect multiple scale. So it's not multiple, it's multi-scale, detect multi-scale method. So in this method we have to pass the three values, I mean three parameters we have to pass. First thing is the image, right? So gray is the image which we turned into black and white one from the real image, which is stored in the object gray, right? So the gray is the image, and next two parameters will be 1.1 comma 4. These, why these only? We can change, no, why these? The reason is these are the parameters which will have better accuracy. Okay, so it will give better results if we use these values. So this is the logic which is used to detect the faces, and the uh, faces where it's situated in the image, where the face is and how many the faces are. Okay, so let's write a comment here. Detects the faces in input, right? Okay, so let's know what the data is in faces, right? So what I will do is print faces. Okay, so let me tell you before the output. Okay, we will see the output next. Let me tell you what the output will be. So in faces contain nothing but a list. It is a list. Faces where object contains a list. In list there are tuples. There will be tuples. So the number of faces present in the image, the number of faces there that the CV2 has recognized from the given input image, that number of tuples will be present. Okay, first thing, clarity. Number of tuples equals to the number of faces that is detected by the CV2 module in the given input image. Okay, second thing, the tuples contains values. How many values? The tuple contains four values. Those are x, y, w, and h. So these are the four values that the tuple contains. Okay, cool. Next, let's run this. Okay, this is the image, gray image. Let me close the image. Okay, sorry. Here the spelling is face cascade. At the end we have to keep e. Okay, let's run again. Yeah, the image is gray image. It's converted, and see here. The CV2 found three. See, three. I mean, three face data is found. So three faces are found. So here three types of tuples are represented here in a list. Okay, in the list, um, three types of lists are represented. Each list represents a face. Okay, so let's draw the rectangle to these faces. So which represents that these faces are detected. So we have to represent that, right? So let's draw a rectangle here. How can we draw that? Okay, we have to go through a for loop. Let me write the logic here. Then I will explain. Come on. This is the for loop. Here for loop, in this we have seen a tuple here. So in this tuple we will this is the first tuple. Okay, so from where it comes, this tuple will come from faces. So faces is a list we have seen, right? In the previous output we have seen a output which is a list. It contains three lists inside, right? So first list, second list, third list represents three faces, and each list in each tuple there are the values, four values, which represents through x, y, w, h. Okay, so the number of tuples, I mean the number of faces is recognized that many times. This for loop will be looping. Okay. So how we draw the rectangle for the faces? In CV2 module there is a method called rectangle. See, rectangle. CV2 dot rectangle, right? No, in this rectangle we're gonna pass the image. Okay. See here we have passed the img variable, which is nothing but a object which stores the colored image. Why we doesn't pass it the gray image here? The reason is that we have used the gray image just to make the process easy, faster. I mean faster. Okay, but we have made the gray image and we have used that, and we even detected the faces from the gray image only. See, detect multiscale method, which is used to detect the faces, is used gray image only, black and white image only. So the real point is here, in gray image or colored image, the values of x, y, w, and h doesn't change. But uh, why we have used gray images? to detect the faces in less time, by using less time and by using less resources, we have used the gray image. So by now we have know the how many number of faces is there in the image and their location in that image, the faces location in that image. So we can just implement that with respect to that locations. We can draw rectangles in the colored image only. Okay, no issue here. So we have passed the colored image as the first parameter. Next parameter should be the x comma y. So in x comma y is nothing but in graph there is x comma y represent a point. Okay, at x axis and at y axis where these two axes gets joined, the point with their form that forms a point, right? So x comma y represents a point here. So why this point? This point will be situated in the top left corner. Okay, in rectangle there are 4 vertices, right? So in top left corner, the on top left vertex this point is situated, right? For each image, I mean for each face, right? In each for each face. Next point will be x plus w comma y plus h. So next point will be next x comma y point will be x plus w and y plus h. Here at point x, what we will do? We will add the width, right? So we will add the width, and at point y we will add the height. Okay. When these are done, the point will be right. The point will be in the top down right corner. Okay, so x comma y will be a point at top left corner. X plus w comma y plus h, this is a point which will be situated at down right corner. So top left corner and down right corner. When you join this line, when you join the line which is touching both 2 points, it will form a diagonal. It will form a cross line which will be a diagonal for our rectangle. So through this diagonal, the rectangle will be drawn for the face. Okay. Next, what we have to do is, in which color the rectangle should be drawn. The line should be there. The rectangular line, four sides line should be in which color? So I am choosing blue color. For blue color, the color code will be 255 comma 0 comma 0. Okay. So another thing is the thickness of the line. The thickness of the line which I want is 2. Okay. 2 represents the thickness of the line. So I have given the 2. So this is the image. Drawing the rectangle to that image which we have detected in the image using cascade classifier XML sheet, right? So since we have got 3 image data in the list, the for loop will be rotating for 3 times, right? Okay, then now what we have to do? Okay, let me represent the comment here for the logic which we have written now. This will be the drawing rectangles to detected faces, right? So for the detected faces, the rectangles will be drawn, right? Next thing what we have to do here. Next thing, we have to visualize this image. Okay, we have to visualize the colored image which has the rectangles to the faces. That means the image, the final image, the output is here. In the output we have to see the rectangles for each face present in the image, right? So how we can do that? So using CV2 module, as we have used the IM show method for showing the gray image, same syntax, same logic should be followed here. So IM show method, and first parameter which is passed in the double quotes will be the name for the image, right? So output image will be the name, for the image, which will be the final image, which has the directory faces with the rectangles, blue color rectangles. So the image which the it should show is img image. So here img in this, after this logic, img image will be having the rectangles for the faces. I mean img object contains the image, colored image, input colored image. In that image, the rectangles will be drawn to the faces. Okay, it will it helps to show, it will show that image, right? IM show method. Next, what if we want to save that image in our laptop? So in CV2 module there is a method called IM write. So using this method, the image, the final output image can be saved into our laptop. So in to this IM write method, the first parameter should be the uh, path where the image should be saved. Okay, and then at the end of the path, what we have to do is use this backslash. Okay, so in this backslash, after this backslash, you have to type the image name which you want to show. I will use output dot jpg. Even you have to give the file extension also, image extension also. Okay, so in the name of output dot jpg, it should be saved. So output dot jpg, as name of output dot jpg, img image, img contents, img object contents will be saved as output dot jpg. The img objects has the image which is the output of this program, right? So since we have created a folder as starting, you can use the this direct names output.jpg. No need, okay, no need of for address, I mean no need for the path. You can directly use output.jpg. Here also, if you create a folder and doing this Python program in that folder, there is here also the image, for image you can directly use image dot image extension. For it can be jpg, png, or jpeg. Okay, your image can be any type. Next, we'll just run the code and we will see the output here. Okay, first we have got the gray image here. See, here is the gray image. After that, at the end, the output is output image. Okay, which we have gave the name here. It should be displayed as output image. The output should be right. So here the three faces are detected in the output image, right? Here are the this is the output, and we have saved that, right? We have saved that in the folder which we have created. Let me open the folder here, and here courses is the folder which we have created. Here output, here is the this is the image, I mean the output image, and this is the image we have which we have given to the code as an input, right? So these are the two images. Okay, so this is the code used to detect the faces in Python using the module CV2, and the uh, technique is higher cascading. Okay, next, the continuation of this, that is to detect the faces in video, right? So detect the face in video. So we will just make this line as comments, and we will write the comments here. I mean uh, the comments for this project. Okay, what the comment will be, mm, showing output image and saving in laptop. Okay, saving in, sorry, system. Okay, saving in our system. Right. Okay, this is the code. We are done with the face detection for images. Okay, we will make this code as okay. There are only respective lines, small only some lines which we have to make as comments here. The thing is, we are reading the image. Now we have to read the video. So we can make this line as a comment. No need of this. Okay. And the remaining things. So we get the output image and we save that output image in our laptop using this logic. This one line, this one line logic, right? Sorry. Yeah. This one line logic, right? So we don't need this logic anymore. Okay, so we will move to the topic, that is to load the video. That is to load the video, right? So how we gonna load the video? We gonna load the video with a class called video capture, which is there in CV2 module. Okay, let's create a object for this cap, which is nothing but a capture. What we have to capture? We have to capture the video, right? So in cap, what we have to write is CV2. In CV2 module, CV2 dot, we will import a class. So that class is video capture, right? So capital V class starts dot capital V I D E O V I D E O small video, again capture C capital capture video capture, and the value which should be passed into this class should be 0 if you are using the laptop camera. If you are using not laptop camera, then you have to pass 1. Or if you want to detect faces in the video which you have recorded and available in your laptop, you have to pass the address, the location of the video which you have in your laptop. Okay, so you have to pass the address here. Now I am passing the live video 0, which uses my laptop camera, right? So in this way you can capture the video. Okay, next what we have to do here, let me explain. Let me go through for 1 or 2 minutes with the concept here. The concept here is we are capturing the video. Okay, it can be a live video or the video which you have in your laptop, that doesn't matter. You are capturing a video. So what does video contains means, it contains frames are nothing but the images. So collection of these images will form a video, right? So these frames, that means the images, will form the videos here. What we have to do is we have to take the video from the user. That can be a live video or that can be a video which they have stored in our laptop. Once the video is taken, I mean in the process of loading the video, what we have to do is we have to make the video into frames, cut the video into frames. That means images, cut the videos into images. So for each image, these 4 line logic, I mean these 4 logic concepts should be applied. That is to converting the image from BGR to gray and then showing that image, and then this is no need basically. But if you want the acknowledgement as that the image is being converted into gray, then you can have this, or else you can remove this. There is no need here. I gave this just for the acknowledgement that the image is being converted into black and white image. Okay, and for this is the main thing, and this is used to detect the faces, and this is to draw the rectangle for the detected faces, right? This is the 4 logics that is required. Okay, so what we have to do is, since we are collecting the frames, uh, each frame undergoes this four logics, undergoes with through these four logics every time. So how many frames does our video contains? We don't know, right? In for live video, the frames will be coming on. It will be not stopping for live video until we close the camera. There will be no stopping of videos, I mean the frames, right? So what we have to do is, we have to go through a infinity loop. There is no option, we have to go through infinity loop. So the basic syntax for infinity loop is while capital T R U E. While true is a infinity loop in while. So while space condition is the while syntax, right? But here I passed the true as the condition. Since true is a boolean value, which represents one, that means the condition in general in while loop, if the condition is true, it will go through the loop. Once the condition is false, it will end the loop. Here I have passed a boolean value which is true. That means one. That means the while loop will goes on, cause there is no end for the while end for the condition to become false, right? Since I have intentionally given the true as the boolean value. Okay, we have to move this indentation, which means the indentation, right? One tab indentation is enough for, right? So I will give the indentation here for everything. And okay, I have given the indentation here. So what the required thing, next thing is, we have to collect the images, that means the frames, right? So how can we collect the frames? Here we are using the cap variable. In cap variable we capture the video using cap variable. I mean cap objects context has the data which is being captured by the camera, right? Cap variable accesses the camera with the help of CV2 module. So in through video capture, the camera will be accessed, and the data which will be coming through camera will be there in cap. Okay, so that in the data we have to root data dot read, I mean cap dot read method. So this gives an output, that is, this gives two values as an output. Cap dot read gives two values as an output. The first value will be nothing but the boolean value, that is whether the frame has read or not. That is, the video will be cutted to mean the video is changed to pieces, right? Pieces of frames. So each piece of frame contain image, right? So we have to check whether the frame has successfully read or not. So if the frame has read it, the boolean value which we get is true. If it is not successfully read, the boolean value which we get it is false. So the first thing is success, comma img equals to, okay, here. So the cap dot read returns two values. So first value will be saved in success, which is a boolean value. That is, if the frame is read, it gives the output as true, boolean value true. If not read successfully, it gives the output boolean value false. It will be stored in success. Next, if the frame is read, the image will be stored. That frame contains image, right? That image will be stored in img object, right? So the video is now becoming the images, collection of images. Here How here the simple concept here, let me tell you some concept here. Here we are getting the video, right? We are getting the video, but what happening is we are making that video into frames. I mean images into frames, which is nothing but images. But at the end we are able to visualize a video. But how that is possible? The reason is the interpreter the python perform this task in milliseconds, in very minute milliseconds, that even we can't able to know, oh, that the image is being shown, not the video. Okay, the images are being shown, the frames which they got uh, been to pieces, been to images. Again those images are being collected and shown as a video. See that fast, that minute milliseconds are taking for by python for doing this all. Okay, so we can't able to differentiate the image or the video here. That milliseconds of time is required for python. Okay, next we have seen the image here. Okay, these should be also in the loop, that which means the image will be shown here. Okay, next, how we gonna end this loop, how we gonna get out of the loop? So there is a logic for this. The logic will be as follows. uh, First let me write the logic here. That is cv2 dot wait k capital wait key of 1. Okay, cv2 dot wait key of 1, which represents that in our keyboard there are different types of keys, right? Different type of buttons which are nothing but keys. So what will happen is wait key will take time to check whether the any key is pressed in the laptop. Okay, so cv2 module uses wait key method to check whether the any button is pressed. Okay, if let's store this content in variable k. So why we have stored this variable means to check whether a respect to sorry we will write a condition. If k double equals to 13, what will happen? See, break. Okay, let me explain this code. Here k stores the value if any key is pressed. What value that k stores? I am telling that a value is stored in k if any key is pressed. What the value is? In ASCII there is a American standard. So that is the value for every alphabet, and values are also given for every key present in our laptop also. Okay, so for enter button the value is 13. That's why if the enter button is pressed, then the k value stores 13, which is a ASCII value. Okay, so if 13 is present, double equals to, so 13 is present in k, then the while loop will be break. Then what should happen? Okay, let's write the comment here first. Getting out of the infinity loop, right? So at the end what we have to do now? So what we have to do is we have started at starting in here we have started to capture the image, right? So in this capture image, I mean capture the video, right? So we have to using this logic, the camera is accessed by the program. For this python program our laptop camera will be accessed. So we have to stop the access, we have to release the laptop camera for being used. So how can we make that happen? We have, what we have to do is uh, cap variable, in cap object, we will just use a method called release. Okay, so we will just using a method called release, so which releases the video capture device, that is nothing but the laptop camera. It will releases the video capture device. Okay, cool. Now the laptop, our laptop camera will be shut it down. After that, cv2 dot destroy all windows. So this is a method which is used to destroy all the windows if any are present. Okay, at the end. So this is used to close the camera. Okay, okay. For this, hmm, what we can write is reading frames from video, right? So these are the respective logics required for the face detection in video. Let's run this and check whether it has errors or not. If it has, we will solve them. Let's see what will happen. Okay, my camera is on here and my face is being detected here, right? See, so my face is being detected here, and here another thing is, yeah, even the gray is also present, right? Even the gray is also present here, gray image, right? So my face is being detected here. You can see the blue box which is representing my face, right? And even the gray image which is being used, nothing but conversion of the black and colored image into the black and white. By using this black and white, by using these black and white, what the program is doing, it is processing the images which are being sent. And what the process is, nothing but locating the face, where the face has situated in that video, using this gray image, right? Using this colored image, what it displays, it will displaying the face which it has detected, right? The detection is done on gray image, but the output will be showed on color image, right? The output will be shown on colored image. Okay, then, so this is the outcome of this course, which you able to learn the face detection in live videos or videos, and even in images also. Okay, thank you. Okay, let's press the enter button so that it will all get closed and all the windows are been closed. Okay, our gray image window and even the output live video window, right? So everything is done. We have completed this course, and I think you have all well understood this course. If you have any doubts, you can directly contact us using our website. There is also a contact us page in our website, so you can go through our website and give us a mail. And we do create I mean, we do have courses, workshops there. We can follow up through that. We can go through that workshops. We will be conducting workshops, and we will be connecting the paid courses also. So make sure you all well okay with our website, well familiar with the website, so every update will be seen on that website. Okay, thank you for supporting us. Please share this video, please subscribe our channel, and have a great journey, have a great success.